This is Dwayne Chandler, AE292, Experiment 4. Now, once again, like the last experiment, I've modified the diagram a little bit to make it easier to show. It was more difficult to put together, but I think the end result's good. It's a bit of a monstrosity. The original schematic, once again, called for plugging and unplugging one of the resistors to see how the two resistors in parallel formed a different level of resistance, basically, that affected the light. So rather than pulling and pushing, what I've got here is I've got the 2K resistor, which, by the way, I'm using a 2K instead of the 3.3 in the book because since we're down to 5 volts, I figured a lower resistance would ensure that we were still getting noticeable results, and B, I can't find the 3.3. So I've got the 2K resistor wired here along with this jumper wire. Now this jumper wire is going to go into one of 3 columns here. Each of those columns is rigged up with a different resistor. All 3 of those resistors are wired onto the same column here, along with the output through the 2K resistor, and this green wire carries the resultant out to our LED to get our results. What I've got now is just the 2K carrying power. So we get a nice bright light. I take the jumper and I add it to the 1K resistor, and we get a better output. I'm going to pull this so you can see the difference. Okay, we move on to the 2K or 10K. You get a little bit of a bump. Oops. But nothing like the 1K, which was back here. And then we move on to the 100K resistor, and it didn't seem to change much at all. The reason it didn't change is because the current for just the 2K resistor was 1.65 milliamps, and when you do the math, the current for the 2K plus 100K only comes out to 1.68. So in effect, adding the 100K resistor to the circuit did very little at all, and I think that's the point.